All right, here we are again, and this is this is, let me zoom in here a little. All right, I think when I last did a video, it was one of the threading videos there, and I was making those nuts for the Porta Power rams, because I said occasionally something will come up where I need to have essentially pullers, pushers, etc. Well, one of those things came up today, and here we are about to make something for it. This is essentially going to be a portable, a portable press, a frame for a press to push a pin out, and very large pin. And essentially what we're going to have is two large, this is 2-inch thick by 5-inch wide, hot rolled, and there's going to be a hole in the middle, and then you can see I've got them spotted. Let me zoom in here. You can see I've got them spotted in here and here. These are actually, I got them spotted because I laid this thing out. I laid this thing out on the mill, and before I started, these are going to be 1.25 inch. Well, I haven't. No, actually 1.5 inch. These are going to be 1.5 inch threaded rods that'll go through here, and then this is going to be the the outside. The pin will actually come through this. I'm getting pretty close. Actually, I'm almost done. I'm going to bore this to slightly over 2.5. That'll be the bottom part, and then let's see if we come over here. This is going to be the other half. There's no need for the large hole in it, so this will just have the 2 1.5 inch holes in it for the threaded rods to come through, and this will be the top. The ram will sit against this and push, the bottom base of the ram will sit against this and push against the the pin, and then that of course will be straddled, and this will be the bottom, and it'll push through this. So I don't know if I mentioned it in any of my previous videos. I'm not overly impressed with milling in general, especially well, I'll call them the Bridgeport. This is a genuine bridge, but any of these Bridgeport type mills, I just don't think they're a good tool for removing metal with the little the little R8 spindle. I guess I'm just not a big fan of milling. I'll probably do a whole video where I can go off about that. But anyway, so when I need to make a big hole, I like to do it in the lathe. So that's why I chose to, and go ahead, let the flames begin. I don't care. Like I said, all part of my bumblebee engineering mentality. I do this often. I do it regularly, and I do it often. I needed to make a really big hole in this. Like I say, I don't want to do it in the mill, with a little boring head going, 30 thousandths or whatever a pass. It would take forever. So I took my, within my 3-jaw, I hold my 4-jaw. Yes, I do this often. Don't know if it's okay. Don't care. That's the way I do it. And then, of course, I held the piece that I'm actually going, boring in the 4-jaw. And for the minimal amount of time it takes to literally throw this in here, and then to set, again, I have some experience, so to dial a piece in off of a layout mark is really quite simple in a 4-jaw. It's not like I'm trying to dial something into a few tenths or something, so it's not so bad. And then of course, it's from there it's just a matter of boring. I'm pretty close now actually, so I just figured I would show you what show you what I'm doing here. That's about it for the moment. Because let me just bring this in here. Because I'm doing very heavy cuts, you know, I want to remove a lot of material. I'm using, I don't normally use inserts. When you see me doing something, it's mostly hand ground tools, be them carbide or high-speed steel. But on something like this, this is this to me is a good time to use an actual insert, because again, because they last really long, and they, you know, they really cut. And you can see actually, let me try to zoom in on this here. You can see obviously the results. I mean, you got some really, you know, nice chips. I mean, they, you know, when they design these tools, you know, they do a damn good job on making these inserts. Like I say, I'm normally not a big fan of inserts, even for my, you know, for my machines. I mean, you know, I have, you know, this is whatever. I guess this is a 14 or 15 inch lathe. This runs, I think, a 5 horsepower motor, and then if you come over to my big TOS over here, you know, that runs, I think, a 7 horsepower motor or something like that. But even so, I'm still not necessarily a fan of inserts for you know, for manual machines that are what I would consider of relatively low horsepower and spindle size. I mean, I'm sure you can tailor them. I know now with the inserts you can absolutely tailor them to pretty much anything. I know little 10-inch lathes and stuff, but like I say, I didn't start that way, and you know, again, glorious or tragic results of a misspent youth, whatever. So I'm not, you know, again, I'm not a huge fan of inserted tooling for manual machines. Again, not because it's the tooling's fault, just because, you know, again, I think with relatively low horsepower machines, I don't think the benefit is all that great. So that's the reason I don't necessarily use a lot of inserts. But like I say, again, this is a perfect example where I think it is certainly a worthwhile thing. I mean, I'm taking you know, 100,000ths at a clip here, and you know, I mean, it's not even, you know, without, you know, any groaning, or well, maybe a little groaning, but you know, but no problem, you know, because again, the tool is so tough, and it's, you know, it's designed for, you know, for doing just that. So anyway, yeah, let me finish, I'll bore this thing, and yeah, and then I'll take it out, and then we're going to come into the mill, and we're going to start drilling the other, you know, the 1.25 I'm sorry, I keep saying 1.25 1.5 holes. But yeah, that's going to be exactly one of those things that I was referring to when I made those threading videos for the Porta-Power. This comes up, you know, pretty regularly, where I need to have a situation, you know, where I have to portably, you know, be able to press or pull or whatever, something in or out, you know. And you know, it's in the evening now, but it, you know, it came up late in the day, and it has to be a go for tomorrow. So here we are. All right, let me cut away, and we'll try to come back to this in a little while. All right. Well, I'm down to my finishing passes here now. So I just figured I'll give you a little shot of, you know, how things are progressing here, and you know, you can see here again, you can hear that chatter and stuff. Again, this is a very heavy insert. You know, it's designed, it wants to make really heavy cuts. I'm only taking, you know, 40,000 with it now, so, you know, this is probably not the ideal situation for it. But, you know, but I don't mind a little chatter. Again, we've got quite a bit of stick out on this piece as well. I mean, again, I've got the, you know, the chuck is holding the forejaw, you know, which is holding the piece, you know, so it's all in all, I mean, you know, it's pretty respectable, you know, considering. So, you know, I think that's a pretty fair deal, and I certainly don't mind a little chatter. You know, and this is not, again, this is just to receive pin come. This does not have to have any particular finish or anything like that. It's you know, just to let the pin come through. So it's nothing too fussy here. Okay, well, this is going to be my my final pass here. It's going to be right over 2.5 inches, so that's about it. And as you can see, this is just about the limit for this lathe insofar as the swing. You can see here how, look at my hand, that's my stop, because I had to, you know, naturally bring the carriage up. So like I say, this is just about the limit for this. I mean, that piece is, that's a 1 foot piece of steel, and oh, I guess we're finished with our cut there. Oh, there we go. So, you know, that's just about the limit, considering it's a rectangle, you know, but, you know, like I said, that's fine, you know, that's pretty respectable for this, this machine. All right, and like I said, we'll, now that we're done, I'll probably knock this thing out of here, a little deburring, and then I'll bring it over in the mill, and we'll start setting up to drill the holes. Okay, here we are in the mill now. We've taken the piece out of the lathe. We finished the hole. Let's see, can I zoom in just to show you? Even though, like I say, those are big, heavy inserts, we didn't do too bad on the finish. I mean, you know, again, considering, you know, it's a very heavy insert with a, you know, a very negative rake, you know, it's not all that awful terrible. Obviously, no problem for what we're going to be doing here. It's fine. Now, here's another interesting little phenomenon. Everybody knows when you, unless, again, unless you have a, you know, whatever, many $100, I guess, Kurt or equivalent type of new style milling vise, certainly which I don't, there's going to be a certain amount of lift on your part. Now, here's a huge, big, heavy part, and I just wanted to include this because note back, by the way, again, with me, everything seems to be almost an opposite of the rest of the earth, I know. But on me, in fact, not only the vise on this mill and the vise on that mill, they're the same vise. I really like these vices. I don't know where I got them, probably at an auction, or somebody was throwing them in a dumpster or some shit years ago. But anyway, I really like these vices. Most people that come in my shop don't like them because this is the movable jaw. The rear jaw is the movable jaw. Again, I've gotten used to it over the years. It makes no never mind to me. If I need to indicate, I indicate off the front jaw. I like them, they're fine. But anyway, naturally, most vices that, again, are not these really fancy ones, they lift. When you put the part in, and you know, you have to knock it back down onto your parallel. Obviously, for what I'm doing here, there's no parallels involved. It's right on the floor of the vise. But here is a classic example of when you tighten the part. Let me zoom in on it. Just stay focused. Look in here. Look how that thing lifts. You can see the amount of lift. Here I'm going back and forth. That this thing, there you go, right? You can see how much lift. I don't know if it's better zooming in or zooming out here. There, you see how much lift this thing has. So in order, I'm sure you probably, if you're familiar with machine and stuff, to correct that, if you simply can't get, you know, by knocking the piece in, there's another way to do that, to rectify that. And again, there's my answer to that. A nice, you know, piece of, well, thick paper. But if you'll notice, now that we put that in there, we're going to tighten the vise up now. And again, you'll see I'm not hammering on it or anything like that. And the piece is not moving. It's staying nice and in place. Okay, that's giving it the grunt there. That's it. It's tight. and no lift. So if you just put a nice heavy piece of normally paper or something that's a very like a piece of oak tag or something, I guess I probably just dated myself with that word, you know, nice something substantial behind it, and I don't think it matters whether it goes between the fixed jaw or the movable jaw. It generally does help to eliminate the lifting of the part, especially when you have a, you know, cumbersome part, something like this. Okay, so that's about it for that. I just wanted to include that because I noticed it and I thought that might be an interesting point to video. All right, so now I'm going to again, now that I have my big center hole, these are going to be 1.5" holes out here. This one, I got it spotted, and light crummy, and that one right there. So I'm going to get on with doing that. Okay, that's one. That's 1.5 inches. I obviously, of course, since this is a, you know, naturally it's not a very heavy drill press and it's an 1.5 inch hole, what I do is I drill, and again, like I said, these, as far as I'm concerned, these, you know, the R8 thing's a little wimpy. So what I do is I get it, you know, as large as I can with, you know, S&D style drills, you know, and then I switch over to you know, to end mills. So that's an 1.5 inch end mill that I finished with, and so that's my 1.5 inch hole. And then we're gonna come over here and we're gonna start another one right there. Okay, so that's one piece completed. We've got the 2.5 inch hole in the middle, and then these are 1.5 inch holes on each side of the 2.5 inch hole, and in those will go a threaded rod, 1.5 inch threaded rod on each side. And as I explained, this will be the bottom, and then I'll have another piece, which I'll do next. This piece, which is the same, and let's see if we can, right here and right here, we'll have 2 more 1.5 inch holes, and the middle on this will remain a blank because that's where it's going to be. The ram will go here and then push against the pin I'm trying to extract, and then it'll come up, push the pin through there, and then it should eject through. You know, the clearance here will be for the pin to come out. So I'll start on that now. Well, we've certainly made some chips here tonight. This is the second piece finished now. So let's see, here we go. That's the second piece, which will, you know, act as the top or the bottom, of course, depending on how you look at it. The ram will sit on this piece and push through, you know, to the other one. So I'll pull it out of here and I'll show you the two pieces together and the idea of how it's going to work. I'll set it up and then that'll be it. Alright, there's what is essentially going to be the, the finished product there. The ram, I just put the ram in there just to, just to give you an idea. It's, again, it's solid on the bottom so that the ram can push off of that. Actually, what I've got here now is this is just the ram I have here hanging around. It's a hollow. This is a 20-ton hollow ram, but it wouldn't matter. I would assume for something like this, you could use a regular solid ram. I made the holes 1.5 inches. I have one piece of 1.5 inch rod here. This is a piece of 1.25 inches. I think for what I'm doing, actually, the 1.25 inches will probably be sufficient in strength, especially knowing that, you'll have two of them on there. And again, I assume that this will be, I'll keep this around because this will be reusable, many times. You'd be able to put, different collars, assumedly, on here, or, naturally, if you wanted to go with a, a stepped type of thing to, push a specific size pin in or something like that, you could do that. But yeah, that's going to be it. And I assume it's going to be just fine. Those are, I guess they're 3-foot pieces, as you can see, of threaded rod. And yeah, that's essentially going to be the finished product. The ram will, live in there and push off and push the pin through up to the hole on the top. And again, there's no reason you couldn't run this way and push from the bottom up, or of course you could always invert this thing, and push, this piece would now be the top and this piece would be the bottom, and you'd be, again, pushing the pin through from the top down. Either way, I assume, would be acceptable. So that's about it. I guess we're going to call that finished for now, and that'll be it. So there it is. Everybody, thanks for watching, and as always, as some famous guy once said, everybody polka. Thank you.